Hello, welcome back. Today what we're going to do is covering the 2023 practice exam. This was an exam given in 2023, the free response question part. And a lot of times, a lot of the questions are similar, have similar concepts, so it's great to go over these. So let's go take care of this one. And we're going to start question number 1. Once again, question 1 and question 2, you can use a calculator for, you get 30 minutes for. Questions 3, 4, 5, and 6, you cannot use a calculator. Customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f of t is measured in seconds since pumping began. Selected values of f of t are given in the following table. You got the seconds and then you got the gallons per second. Using the correct units, remember to use your units, interpret the meaning of the integral from 60 to 135 f of t dt in the context of the problem. You're going to use a right Riemann sum with 3 subintervals. 90 to 60, 90, or 60 to 90, 90 to 120, 120 to 135 to approximate the value. Now the difference between a left and a right Riemann sum is if you take 2 values like there, when you're using a right Riemann sum, you're going to use the f of t from the right side. If I was doing this value right here with a left Riemann sum, I would use the value of f of t from the left side. That's the only difference in the left side and the right side Riemann sums. All right. In the 2024 free response questions that they gave, they used the left Riemann sum. So it's good to use and know each one. All right, so here we go. First thing you need to know is your t in seconds. That is going to be your delta x pretty much. And your f of t is going to be the inside of the stuff that you are subtracting as well. So the amount of gas being pumped into the tank is what we're actually looking for. And that is very important. It's going to be from 60 to 135 seconds. So that's actually telling us right here what we're looking for. So how much gas is being put into the tank from 60 seconds to 135 seconds. So that right there is the first part of the question. Using correct units, seconds, okay? And you can say the amount of gallons of gas being pumped into the tank between this, so that would be answer your first question. That gets you a point. Second one, we're going to use the Riemann sum. Riemann sum or Riemann sum is the sum from 1 to whatever number, f of ci delta xi. Now in this case, our f of ci is our f of t. All right, so it's your f of ti. Since it's the right side, it's going to be the right one. If it was the left side, it'd be f of t I minus 1 times delta ti. So the difference in your t's. All right, so in this case, it is going to be, oh, actually I should just put delta t there. Ti, which is your right side, right? Ti minus 1. Oh, I forgot my f there. A couple mistakes on this. All right. So we got that. Let's see how this works. So the first one, f of 90, since we're going from 60 to 90. This is the first one. So we're using this box right here. It's going to be f of 90, which is 15, 90 minus 60. And then we go to our second box. I'm going to pick some weird colors here to help us out. I'm going to get some colors here. Our second box is from 90 to 120. So it's this box. It's going to be f of 120 times 120 minus 90. All right, and then we got our third box. I'm just trying to pick colors on these later on. Right here, which is 120 to 135. So that's going to be f of 135 times 135 minus 120. F of 90 is 15 times 30. F of 120 is 0.1 times 30. F of 135 is 0.5 times 15. Multiply them all together, and you get 8.25. All right? And that's your answer. That's all there is to it. Nothing really difficult. You can use the calculator if you want to do the math, but like you said, you don't have to. All right? Good? Awesome. I'm going to do that there for a second for you, so you can just observe it and answer questions that you want. All right? Go to the next one. And like there's going to be a couple questions, little mistakes made in these just because I just made them. Haven't really So there must exist a value of c, for c is between 60 and 120, such that the derivative of c equals 0. So justify your answer, derivative of f of c. What we're doing here, this question is going to use, think, the mean value theorem. Okay, once again, we did this before. It is pretty much the slope formula where f prime c, the actual derivative of the equation, equals f of b minus f of a over b minus a. Now in this case right here, this is good because our b is our second term and our a would be our first term. All right, so when we're dealing with this, first thing you need to know, is f differentiable? Yes, you can differentiate it. Also, f is continuous. Those are two important things for it to be a mean value theorem. How do we know it's differentiable? It says it. All right. Also, we know it's continuous because the gasoline just keeps on being pumped. You can't just like cut off the gasoline, take it away, and put it back. Not possible. All right. Customer. Here we go. F prime c equals f of b minus f of a. So our b is 120. So our f of b is 0.1. All right. Our a is 60. So our f of a would be 0.1. All right. F of 120 minus f of 60 over 120 minus 60. 0.1 minus 0.1 over 120 minus 60. 0 over 60 is 0. So is there a value? Must there exist a value where it equals 0? Well, yeah, look at 0 is what we wanted, and that's the answer. So yes, it is true using the mean value theorem. And that's it. So far, 2 questions, 2 very easy questions. All right, ready for C? Now we're going to jump into letter C. And pause it if you have any questions. Pause it, look at it, observe it. Oh, gave the answer away. This one's going to use the average value of a function, which I said in previous lessons, is seen in almost every single free response question year. So right now, the rate of flow of gasoline in gallons per second can also be modeled by G of T equals, so they give you an equation for the rate of flow of the gasoline. Rate of flow of the gasoline is the velocity of gasoline, which is the derivative of F of T. All right, so using the model, find the average flow rate of gasoline. Now the average flow rate, okay, when it says over the time interval, is what tells you to use your average function of a function over average value of a function over an interval. Now what exactly is our interval? Well, we're going from A to B. So this is pretty easy. You're going to use your calculator to solve this. It's going to be 1 over B minus A, 150 minus 0. From 0 to 150 of T over 500 cosine T over 120 squared. Now I'm going to do just one question with the calculator. I'll do the calculator with you. But we're going to use our calculator here. So what you're going to do first is you're going to go to your calculator. You're going to make sure, in case this is the only video that you watched, your calculator is in mode, and make sure that it is in radian. Don't mess that up. Clear out. All right, so to use this, we're going to go to math. You hit the math button right here. Math, and then we go down to number 9, and we hit enter. Now we're just going to type in these numbers, 0, 150, okay, 0, 150. We're going to click over, and now we're going to do parentheses. Instead of T, we're just going to use X. X button's right here. X divided by 500. Close the parenthesis right there. Open and close parentheses. And then we're going to hit cosine. Cosine's right here. Cosine. All right, we're going to have to open 2 parentheses. I know just one because I already have one open. And it's going to be X divided by 120. Close the parentheses. We're going to square it. All right, and then we close the cosine parentheses. All right, then we press to the right, and we have to put dx. So that's what your equation should look like. And if I did it right, I should get my answer and hit enter and get about 14.4. I left that there so you can pause it. And on the board, let's see, 14.4. So once again, what you do is you're gonna hit the math button. You go down to 9. All right, you type in your A. you type in your b. Here you type in your f of x, whatever that is. And then this, you got to make sure you put x. All right, you hit enter, and it does all the work for you. Now here's the key. This is just this part right here. So this is this part right here. Don't forget about your 1 divided by 150. So you have to take that number divided by 150. Whoop, do that right in your calculator, and you get 0.0959967. All right? And that shows the setup to your calculations. It shows how all the work is done, and now you get credit for a nice, easy question. All right? The more of these that you practice, the more of these that you do, the easier they become. So try to do at least 3 free response question test examples. The more you can do, if you can do 6, that'd be even better. All right, let's see. Letter D. Using the model G defined in part 2. This is G defined in part 2. What we're going to do is find the value of G prime equals 140. Now we said before, G of T, this is G from part, sorry, not part 2, part C. We're going to interpret the meaning as well. So in order to find the derivative of this at 140, what do you think you do? Calculator. So first thing we're going to do is, if you want to do this and use your rules here, we can actually, before we use the calculator, solve this. So let's find the value. I'll show you how to do it with the calculator without. So this is a product rule, F and G. F prime would just be 1 over 500. This one, you kind of have to use your chain rule, where U is T squared over 1440. All right, F of U is cosine U. U prime would be 2T over 1440, or T over 7,200. Negative sine U. So this would just be negative sine U times T over 7,200. Negative sine, plug your U back in, T over 1440 times your negatives up front. All right? Now, where you do the product rule, pretty much like a cross multiplication. You got T times 500, T over 500 times negative T over 7,200 sine T squared over 1440 plus cosine T squared over 1440 equals 1 over 500. We can combine those terms. It becomes a T squared. It becomes a big number on bottom. This number, if I put zeros here, 3,600,000. All right, nothing combines over here, but I do like to drag that to the front. And what you can finally do is you can finally plug your 140 in. If I plug my 140 in, type it in my calculator, I get this is an answer, which is negative 0.00491, which is my answer. Now this seems like a lot of work. So what this says is the rate at which the tank of gasoline is flowing into the tank is decreasing at a rate. This is the important part. You tell what it is. It's decreasing because it's negative. Positive, it's increasing at a rate of 0.00491 gallons per second. You have to tell the units. At the time is, when you say time, always do time T equals 140 seconds. Now you didn't really have to do all that work. You could have just used your calculator, and I'll show you how to use your calculator to solve this. So that's just a little practice on product rule. So to use the calculator to solve this, you're going to go to math again. All right, you're going to go down to number 8 this time. 8 this time is derivatives, that one right there. You would enter d dx, everything's d dx, and you type the equation in that we typed in before, parentheses, x divided by 500, close parentheses, oop, that's a 50, 500, cosine, whoop, there's my cosine, oop, open two parentheses, we already have one open, x divided by 120, close parentheses, I'm doing this blind, and then with x equals, x here equals, they said 140. So if you type in something like this, instead of doing all that work, it should spit out the answer, and it spits out negative 0.0049. All right, 491, which is the exact answer we got. So if you want to do this instead, that's fine. Math, and then 8. And that goes. And you're done. All right? Next one. I just wanted to get a product rule. Problem number 2. Steven swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Steven's velocity is modeled by v of t equals 2 n/3800 e to the negative 200t sine pi over 56t, where t is measured in seconds and v of t, which is your velocity, is measured in meters per second, okay? Find all the times t in the interval from 0 to 90 at which Steven changes direction. Now, when he changes direction, what happens is your velocity changes. And what does your velocity do? Well, when v of t equals 0, that means your velocity is about to change. Because when your velocity goes from positive to negative, that means you're going from swimming forward to swimming backwards, okay? And right at this point, your velocity equals 0. So here your velocity is positive, here your velocity is negative. And you could do it the other way. If I'm swimming backwards with a negative velocity, and then I turn around and swim forward with a negative velocity, right at one point between the two, velocity equals 0. It's a simple negative number line trick. So when velocity goes from positive to negative or negative to positive, that's where your v of t equals 0. Now, we know what the v of t equals. We set it equal to 0. Now, this is another trick that you can use your calculator for. We are going to use the graphing tool in our calculator to solve this. So if you enter both functions into your calculator, I said I wasn't going to do this in the calculator, but I'll do each one once. So I go to my calculator again, and I hit y equals. All right, I already have functions in there. I'm going to clear them out. So my first function is going to be that big one, 2.38. I'm not going to type it in front of you just because it takes too long, and it hurts my arm. E negative 0.02. X, instead of t's I put x, put the right button. Sine, the parentheses are already open for you. We're going to do a pi. Where's pi at? I lost pi. Oh, right where the caret is. Pi divided by 56. No, pi t. So pi x divided by 56. Close parentheses. So that's what I have right there. And the pi button is right here. All right, so I got that. I hit enter. And my second one, I can type that for you, is 0, because we want to know when it hits 0. All right? So after you do that, we have our things. If you hit graph, my graph's all messed up. Oh, no, it's not on my graph. All right, but I could pick something around where I want. Now, since the t time intervals is from 0 to 90, when I hit my window, here's my window button, my x value is going to be -1, and my maximum is going to be 91. I like to just go a little bit more. I make my scale like 10, make it a little big. My y minimum, I want this around 0, so I'm just going to go from -3 to 3. Okay, so as long as that's around 0, I'm good. And I hit graph, and I see what my graph looks like. All right, I see my graph hits at 0, 0. I see it hits again, and it hit like twice. All right, so when it goes from positive to negative or negative to positive, so when it hits 0. So when I'm looking at this graph, I need to use something else. All right, I am going to go, I typed in my numbers, I typed in my windows, and I got my graph. Now at 0, 0, that's the start, so that doesn't really matter. What we care about is this point right here. So the way we do that is we're going to hit Calc 5 intersect. You put an X on this graph, an X on this graph. You make sure your next one's towards here, and it puts right there, and it gives your intersection. And when you tell your intersection, you're going to say your X value, because we already know the Y value is 5. So the way to do this with this calculator is right here. Second, this button right here, boom. We go down to 5, enter, enter, enter. That hits both lines. We go over towards that intersection point, and we hit enter. And then what it does is in the bottom left, intersection is x equals 56. And that's our answer. 56 seconds. Okay? And that tells us the reason. The reason is here. All right, 2B. Find Steven's acceleration at t equals 60 seconds. Show the setup for your calculations. indicate the unit of measure. If Stephen is speeding up or slowing down at time t equals 60 seconds. So this problem right here is a velocity to acceleration problem. And what you should know is acceleration is the derivative of velocity. So if we take this velocity equation and we derive it, we get the acceleration. So at t equals 60, we could type this right into our calculator. I'm just going to leave it up here. You don't need to see how to do the calculator again. So I'm going to take the derivative of the velocity equation when t equals 60. So once again, in your calculator, you hit the math button. I'm just going to hold it over here. Like I said, I'm not going to really do it. So I hit math, and then I go down to number 8, and it gives me this. All right, I'm going to type in my equation here, and make sure right at this point right here, you make sure you put x equals 60, okay? And remember, we're using the x button instead of the t's. I could do pi divided by 56 times x, okay? Or I could do pi x divided by 56. Either one's okay there. But anyway, I get this as an answer, which is negative 0.36013. So the acceleration at 60 seconds is going to be a negative acceleration. So in order to find out if he's speeding up or slowing down, you have to see what his velocity is as well, okay? So we have his acceleration, okay? That's step 1. So step 1 was find the acceleration and show the setup for your calculations. This is our setup. This is us showing the answer. Obviously, you can't post a picture of your thing. All right, now we have to find the velocity. The velocity, we're just going to take this equation and we're going to plug 60 into it. Now, what equation? The original equation. So anytime you see a t, you plug 60 in, plug it into your calculator. 2.38 e to the negative 0.2 times 60, sine, open parentheses, 60 pi divided by 56, and you get this is an answer, which is negative 1595. What do you notice about both of these? They are both negative. Now here's your explanation, your reason. Your reason is, since they're both negative, it is speeding up, okay? That's your reason. Speeding up is your answer. Since the acceleration and velocity are both negative, they're speeding up. If they were both positive, it would also be speeding up. If one was positive and one was negative, or vice versa, it would be slowing down. So opposite signs, slowing down, same signs, speeding up. All right? Once again, this is on tons of free response question exams. Good to know. Let's go to C. All right, C is going to be a distance. Find the distance between his position at time 20 seconds and time 80 seconds. So anytime you see the word at time 20 seconds and his position at 80 seconds and the word between, something should be going off in your head. Let's see if you understand. And distance, distance from velocity, something also should be going off in your head. Distance is s of t, which is the integral of velocity. So the positional function is the integral of the velocity function. All right? So the position function is from A to B. A is obviously 20, to B, which is 80. Your larger numbers always come second. All right? So this is from 20 to 80 of, you're going to type in your original equation, once again, all right, dt. How do we do this? We're going to use the calculator, math 9. And when you type in your calculator, that's what it looks like. So on your calculator, once again, you're going to hit the math button. You go down to number 9. Whoops, went over to number. And you hit enter. You type in 20 and 80, and then you type in the equation. All right, and you should get 23.38 as an answer. All right, I already showed you how to do this, so I don't have to show you again. And that's your answer, 23.384 meters. Make sure you do your units. A lot of points lost with no units. All right? That was pretty easy, wasn't it? And here's your setup. Setup, right here. That's all you have to do. Very, 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 very easy. All right. And that concludes. Nope, no, it doesn't. I lied. There's one more. Find the total distance. Now, this word total is a big word. Total distance is different than distance. When you see the word total distance, what goes on in your head is a different formula. S of t equals the value from A to B of the absolute value of B of t. So a total distance does is it takes all the negative values and all the positive values, and it just makes them all positive and adds them together. It's like if I said I ran to the school back to my house, how far did I run? Well, technically you didn't run anything, you ran 0. But if I said what was the total distance from my house to the school back to my house, there would be a distance, okay? So you're adding this, you're adding this, you're adding this, you're adding all the distances. So in this, you're going to do the same thing, but you're going to use the absolute values on your computer. So math, once again, we're going to go through this. You're going to hit now math number absolute value. You're going to put in the absolute value symbol and type it in, and you should get 62.1642 meters. Notice that's bigger than the other answer because you're combining negatives and positives. So here's how to do this on the calculator. This is one that's good to show. I'm going to hit math, and then I hit 9. I can just actually touch the 9 button. So I'm in my integral. I'm going from 0 to 90, which is a little different than the ones we had before, so the numbers don't really matter. Now, once I go in here, I have to hit math. All right, I go to the right to number, and then right here at 1 is absolute, and you can see 2 little absolute value symbols pop in there. Now you got 2.38 E, so E is second, ln, negative 0.02 x. I press to the right to get out of there because I'm writing the exponent still. Sine, parentheses are open. Where's pi? Second, up arrow, x divided by 56. All right, and I close those parentheses, and I go dx. All right, so that's all you have to type in. And then when I type that in, I ended up hopefully doing it right, and see how it takes a little longer? Your computer's not frozen, it's actually doing all this work for you, 62.1642. All right, you have to use the absolute value symbols, or you're gonna get the wrong answer, and you get no points instead of 2 points. Nice and easy. All right, so 2 questions down. You could also do it a different way. You can go from 0 to 56 where you know it's positive, and then subtract this where you know it's negative, but that way it's too difficult. That way's not fun. All right. Problem 3, slope field problem. You're gonna see a slope field problem, no doubt about it, somewhere during your test. Bottle of milk taken out of the refrigerator and placed in a pan of hot water. So now you can't use your calculator anymore. The increasing function m models the temperature of the milk at time t, where m of t is measured in degrees Celsius, and t is the number of minutes since the bottle of water was placed in the pan. All right, m satisfies the differential equation, d of m over dt equals 1/4 of 40 minus m. At time t equals 0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t negative less than 40 for all values of t. So here's a slope field, and here's the equation of the slope field. They want you to sketch the solution of the curve through 0.05. So very simple, you do this right on your paper. The first thing you do is you put down 0.05, 0 over 5 up. So I put a point. The next thing you do is these lines show you what the graph looks like. So from this, I see this right here. So I'm gonna draw a line that has the same slope as this. Now next, I go here. Okay, it comes a little bit here. Try to keep it almost like between the slopes. You could touch them, but see how it curves over, kind of gets flat, stays a little flat. Now here's the key. This is the key to your slope field. See how this is absolutely flat? That means that's gonna be a horizontal asymptote. So you're not gonna wanna cross that. You're just gonna wanna keep on going here, and if you really want to, you can put a little arrow on the end. You don't have to, but you could tell that's gonna be a asymptote. And right there, you get a free point. Anyone should be able to, it's almost like connecting the dots. All right, so there's your slope fields. All right, B, use a tangent line to the graph of m at t equals 0 to approximate m of 2. The temperature of milk at time t equals 2 minutes. So a tangent line, once again, you're gonna be using point slope form. You have to find the slope and you have to find 2 points. This gives us our, where's it? T equals 0. 5 gives us our 2 points, so that's important. And our tangent line, like I said, is point slope form. So we need our 2 points, and the slope is the important thing. The way to find the slope at this point is we could take our m and we could plug it right in. So we want to find the derivative, we know that, of this function right here at t equals 0. All you're going to do to find that is plug in 5. Because this already is the derivative. This isn't the regular equation, this is the derivative equation. So the derivative of, or the slope of the Melk equation, the slope of dm is 1/4 of 35. All right? We can plug that right in here. Sometimes these questions are too easy. They actually make me think I'm doing it wrong. All right, so I got my, right here, that's going in for my m, which is this. All right, now, these are my x1, x2. x1, right, y1, or m of t1, and this would be my t1. So this goes here, this goes here. Is that enough arrows for you? So you got 5 plus 35 over 4, t minus 0. 5 plus 35 over 4t. All right? Get that mess out of there. And they want to know at 2 minutes. So now I can take my 2 and I can plug it in. So m of 2 equals 5 plus 35 over 4 times 2, which is 35 over 2. All right? That is 17.5 plus 5. 5 is the same as 10 over 2, so that's 45 over 2, which is 22.5. All right? Not very difficult at all. Whoop, whoop, boom. All right? Look at it, observe it, figure out what you did. All right? Next one, 3C. 3C. Oh, wait. Oh, don't forget your degrees Celsius. Degrees Celsius is important. All right. You need units. You need units. Write an expression, the second derivative in terms of m. So we're going to use the second derivative to determine whether the approximation from part B is an under or an overestimate. This wasn't used in 2024, but 2023, 2022, I think 2021, they all used overestimates. Good thing to know. And all it deals with is concavity. So what you're going to do is you're going to derive this equation. So the easiest way to derive this equation is first thing you're going to do is distribute this. So 1/4 of 40 is 10 minus 1/4 of m. So if I take the second derivative of this, the derivative of 10 is 0 because it's a constant. Derivative of 1, negative 1/4 m is just negative 1/4 m. All right, now we're deriving it in terms of t. So this m becomes dm dt. All right, remember, you're deriving it in terms of the bottom. All right, so constants are still 0, but because these variables do not match, that's why you got your dm dt. All right, 90% of the time someone gets this wrong is because they forget the dm dt here. Now, what we do know is dm dt, we know what that equals. This is dm dt, so we can plug that in right here. All right, that way we have our m back. All right, because it says in terms of m. So d squared m over dt squared equals negative 1/4. Combine like terms. So you can combine all this stuff. First thing I'm going to do, negative 1/4 times 1/4, negative 1/16, right? And then what you can do here is you can combine this if you want. You don't have to though. But what I do know is I know m is going to be less than 40. Okay? How do I know m is going to be less than 40? Well, it says it. Because m is going to be less than 40, that means that this is going to be like 39.999 and less. So 40 minus all this, that means this is always going to be a positive number. All right? So that's also from the horizontal asymptote on the graph we had, and it's from right there. So this is going to be negative 1/16 times a positive number, meaning this number is always going to be negative. So the second derivative is always negative. Negative derivatives mean concave down. Negative is concave down, positive is concave up. And this is when you have your second derivative. All right? So second derivatives, negative concave down, positive concave up. So since it's concave down, the tangent line is going to be above the curve. Since the tangent line is above the curve, it's an overestimate. All right? So because it's concave down, this is where it gets a little confusing. Your tangent line is going to be above the curve because you don't want your tangent line going through the curve. If it was concave up, which it's not, your tangent line would have to be under the curve, so it would be an underestimate. So concave down, overestimate, concave up, underestimate. Most of the time. There's some tricks that aren't true, but every time I usually see it's like that. All right, 3D. Come on. Froze. There we go. Use separation of variables to find an expression for m of t, the particular solution to the differential equation dm dt equals 1/4 40 minus m. All right, with the initial condition where m of 0 equals 5. Separation of variables, what you're going to do is you're going to get everything with an m on the same side as dm, and then you're going to put dt on the other side with anything that has a t. In this case, though, there is no t, so the key is to get the 40 minus m to the right, left, and the dt to the left. So first thing I do is I divide everything here by 40 minus m, both sides, dm over 40 minus m, and then I multiply both sides by dt, so that crosses that out. So the dt goes to the right, almost like a cross multiplication, the 40 minus m goes to the left. I do both sides, I only wrote it once because I don't have much space. Now, I could integrate both these sides. So I'm going to integrate this side in terms of m, this side in terms of t. So because I'm doing that, the variables match up. It'll get rid of all the dm and dt's and all that fun stuff. This one you should know how to integrate. You're going to use your substitution method. We know that u is 40 minus m, and du is negative m, the negative dm. Now because we're replacing dm, we want to replace dm's going to be, and I can even put this as u prime or du, because u prime equals negative dm, that means that dm can be replaced with a negative du. All right, so our k is negative 1. So this dm becomes a negative du, so we're going to add a negative to the equation. It becomes the negative du over u. All right, which is the integral of that is just negative ln u. Plug your u back in, negative ln 40 minus m. All right, integral of 1 over u is ln u, and the negative comes from our k. Go to delete some of that to get that off the board. Integral of 1/4 dt is simple 1/4 t plus c. Now I could have put the c on either side. I put it on the right just because that's where pretty much they always put it. All right. Now, because if this is c1, this is c2. c2 minus c1 is just c3, which is still a constant. And we're still going to solve for it. Now that we got our equation, what we're going to do is we're going to use our initial condition. Our initial condition is going to allow us to solve for c. So our initial condition right here says that t equals 0 and m of t equals 5. All right, that's our initial condition. So we could type in m. All right, m or m of t is 5. All right, t is 0. All right. 40 minus 5 is 35, so this is negative ln 35 equals 0 plus c is c, and negative 35. So what can I do now? I can actually take this and plug it into my equation. And I get a cool little equation. Negative ln 40 minus m equals 1/4 t minus ln 35. So now I have an equation, but the only thing they ask you to do here is find an expression for mt. So I have to get m by itself, all right? I put it as mt is fine. So I have to isolate it. The way to do this is, first step, we're going to take both sides and multiply them by negative 1. All right, I'm just going to put this in the bottom, get this out of the way. All right, both sides by negative 1. This becomes positive, this becomes negative, this becomes positive. Next, to get rid of the ln, I have to e both sides. All right, so I get, cancels out the ln, 40 minus m equals e to the negative 1/4 ln 35. Now when I do this, what I know is e to the a plus b, where this is technically my a and this is technically my b, equals e to the a times e to the b. All right? So this right here is 40 minus m is e to the negative 1/4 t e to the ln 35. And we know e to the ln 35 just cancels out and becomes 35. All right, e to the ln a equals a. So 40 minus n equals 35e to the negative 1/4t. We're still solving for n. So we're going to subtract 40 from both sides. And then finally, we multiply both sides, once again, by a negative 1. That becomes negative, that becomes positive. I like to always put my positive numbers first. So my answer is m equals 40 minus negative 35e to the negative 1/4t. If you want to put negative 35e to the negative 1/4t plus 40, be my guest. But that is what my m or my m of t equals.
The LEA is
All right.
voting for their bylaws.
So,
Please come out and vote in room 321. Thank you.
any questions? No questions? Awesome. Number 4, the function. So that was number 3. Number 3 is done. We're all good. We're up to problem number 4. The function f is defined on the closed interval of negative 2 to 8 and satisfies f of 2 equals 1. The graph of f prime, the derivative of f, consists of 2 line segments and a semicircle as shown. Does f have a relative minimum, relative maximum, or neither at x equals 6? And now you're going to give a reason. Now, on what open intervals, if any, is the graph concave up or concave down? Relative minimum, relative maximum is the first derivative. All right, so when you do the first derivative,
If you're in the academy and you need to vote, you can go into room 103.
the first derivative, you're going to be greater than 0. Now, note, this is the graph of f prime. It's not the graph of f. So anytime this graph is greater than 0, that means that this graph is increasing. So from 2 to 6, it's going to be increasing. Okay? Is it increasing anywhere else? It's also increasing anytime you're going from 6 to 8. Look at it again. There's one more place. So anytime f of prime x is greater than 0, it's from 2 to 6 and 6 to 8. Okay? Now, the reason you're looking at just these two numbers, and we know right here it's also increasing, but we don't care about that number because we want to know what it's doing here. So from these points at 6 is going from up to up. So is that a relative max, relative min, or neither? It's actually, it increases on both intervals. So it is, oh, there's my little arrows, almost matched and perfect. It's neither. All right? So neither increasing nor decreasing. Okay? If it was a minimum, you'd have to go from decrease to increase. Whoops. I like to use the different colors. If it was a minimum, you'd have to go from maximum, increase to decrease, minimum, decrease to increase. All right, now since this goes increase to increase, that's a neither. A neither is increase, increase, or decrease, decrease. Second one, what open intervals is any is the graph concave down? Now it's concave down when your derivative graph is decreasing, okay? So when the derivative graph has a negative slope, that's when it has a negative concavity. So now we're looking to see, when is this graph going down? Well, it's the negative slope of f prime x. So anytime it decreases, very good, from negative 2 to 0 it's decreasing. Increase, increase, oh, look at that. It decreases also from 4 to 6. So it decreases in 2 spots, from negative 2 to 0 and from 4 to 6. Therefore, it's concave down in those. It's actually concave up from 0 to 4 and from 6 to 8 if they asked you that question. Right? All right, let's go to the next one. Now we're going to get a little low. So this one has, that one has no maximum or minimum. All right. All right, so this one's L'Hopital's rule. Find the value and show that it doesn't exist. Well, the first thing you know with L'Hopital's rule is you take the highest degree term on the top and the bottom. The second thing you know is if that doesn't work, say I went to type in a 2, what's f of 2? F of 2 right here is 1. How do I know that? wait a second. Oh, this is the graph of f of 1. Sorry. How do I know f of 2 is 1? Whoop, it says it right there. All right? So if I typed in f of 2 here, made this an f of 2, 6 times f of 2, that's when x is 2, so 6 times 1 minus 3 times 2 over 2 squared plus that is 0. Undefined. Right away, wait, maybe it doesn't exist. Well, we can use the rule, say, if you are undefined, you're going to derive the numerator and derive the denominator, then you're going to try again. This is called L'Hopital's rule. All right? Your limit as x approaches 0 is f of x over g of x equals the limit of x approaches 0 of f prime x over g prime x. So when we derive this, this becomes the top 6. What's the derivative of 6f prime x minus 3 over 2x minus 5. All right? Now, this is going to be f prime of 2. How do we find f prime of 2? Well, we have our f prime graph. F prime of 2 equals 0. So to do this problem, very simple. 6 times 0 minus 3. And x here still equals 2. That's where that comes from. Negative 3 over 4 minus 5, negative 3 over negative 1 equals 3. Right? And that's your answer. So the limit at this point is 3. Pretty simple. All right. D, last one. Absolute minimum on the closed interval. Absolute minimum is the absolute lowest point. So the first thing you want to do is you want to pick the start point and the end point. Those are always important to pick. And then you pick any point where it crosses from negative to positive. All right? So those are the points we check. Now when we do this, f prime is 0. Okay? F prime x equals 0 at this point, and this point. Okay, at negative 1, at 2, and at 6. Why? Because it goes from negative to positive or positive to negative. We also know that the top is always positive, the bottom is always negative, so that's where it goes from increasing to decreasing. Now a minimum, okay, we're going to make a little table of values or a justification table, I forget. But an absolute minimum means you're going from decreasing to increasing. Okay, so right away, absolute goes from a negative to a positive at prime x value. So right away we could look at this and we could say some of this stuff doesn't make sense. So we're going from positive to negative. Minimum goes from negative to positive. Oh, this is backwards. Get rid of that. All right, negative to positive. All right. So the way this works is negative 1 is a local maximum. Right here. Oh, that was right. Negative 1 is a local maximum because look what happens. It's going from positive to negative. Okay, we want to go from negative to positive, so negative 1 cannot be correct. All right, because it's going from increasing to decreasing. That's a maximum. Next one we could check is at 2. This one goes from decreasing to increasing, so that could be good. That's given. We know that f of x equals 1. All right. Let's see. 6. We're going from increasing up here down to decreasing. Oh, actually, we're going from increasing to increasing because we're positive, positive. All right. Here we're positive. Here we're positive, and in these cases, negative. It's where the graph is, not which way the graph is going. All right, so that's positive to positive. So right away, 6 is not a max or a min because it increases, then it increases at x equals 6. I think we said that in problem A. All right, next one, we can look at problem 8, but because it's going from increasing to something, we don't know. This may be a decrease or an increase, but it doesn't matter because this can only be a max or neither. All right? So now it may be negative 2. So far this is a bad one, this is a bad one, and this was a bad one. So maybe it's negative 2. So what we have to do is you have to integrate it. Now to find out what the area of negative 2 is, I'm going to clear all this junk off. It's going to be f of 2, because we know what the value at 2 is. We know f of 2 equals 1. And this really is an f of 2. I'm just using this graph as a thing. all right, minus or plus the integral from 2 to negative 2. So we know what this is. If we add that to this integral right here, it'll give us the actual value here. Because this is positive to a negative, if we flip it, we have to change the sign from negative 2 to 2. You always want to have the lower number on as your a, so we have to do a there. And how do we find that out? Well, we can use areas. The area is a triangle, 1 and 2, that's our base. All right, base is 1, height is 2. 1/2 of 1 times 2 is 2. All right, right here, this is 1, 2, 3, and the height is 2. 1/2 of 3 times 2 is negative 3. So this has an area of 2, this has an area of negative 3. So the integral from 2 to negative 2 is negative 1. Or negative 2, sorry, wait. 1/2 of 2 times 1 minus 1/2 of 2. Oh, this is.
Pardon the interruption, Kamaya Philip, please report to the Academy main office.
Right.
Kamaya Philip to the Academy main office.
That's
Thank
1, and that is 3. Now, 3 is a higher number than 1. Since 3 is higher than 1, our absolute minimum is at 2. And that's how you do that. All right? That took a lot of effort. Luckily, that wasn't in 2024. All right, so that's 4. We got 2 more. We got 5 and 6. So x equals 2 is our answer. The functions f and g are 2 times differentiable. The table shows the value of the functions and their first derivatives and selected values of x. Get out of there. All right, so h be the function divided by h of x equals f of g of x. All right, find h prime. Wait, there's no h prime. Oh, we can find it. Of 7. So we could do this using one simple rule, and that would be our chain rule. We can go back and use our chain rule, where h of x equals f of g of x. Very simple. And then we have all the answers for our chain rule here. Our u, our inside is g of x, right? Our f of u is f of u. What's the derivative of g of x? G prime x. What's the derivative of f of u? F prime u. All right? Here's the only tricky part. We just take our u, whoop, and we're going to plug it back in. So it's g prime x times f of u, and our u is g of x. So f prime of g of x times g of x is what h of x equals, or h prime x. So this is h prime x. We want to know h prime of 7. So now we're going to go here, and we're going to go, okay, h prime of 7 equals f prime g of 7, g prime of 7. So all the x's equal 7. We're going to go on our 7. When x is 7. G of x is g of 7. So I'm using this column because this is when x is 7. G of x, see how they intersect right here? That's 0. And g of 7 is 8. So that's 8. This is 0. So what you get here is f prime of 0 times 8. So now what we have to do is go to f prime of 0. So now we have x is 0, and we're going with f prime. So it's 3/2 times 8, and this one I just use this. 3/2 times 8 is 24 divided by 2 is 12. And that's it. Actually a very easy problem to do, and you should have no trouble with it. All right, let's go to B. Let k be a differentiable function such that k prime equals f of x squared times g of x. Is the graph k concave up or concave down at a point where x equals 4? Give a reason for your answer. Now, concavity has to deal with derivatives. All right? The second derivative of something, if it's positive, it's concave up. If it's negative, it's concave down. Now, they give us k prime, and we can use the product rule with the chain rule to find out what it actually is. So we need to know the graph of K. So we need to know what K double prime is, okay? If it's positive, it's concave up. If it's negative, it's concave down. So we're going to use the product rule and the chain rule. Try it out real quick. Don't just follow me, do it on your own. All right. So the first thing, your F is f of x. Your G is g of x. Now when you find your F prime, you're going to have to use your chain rule. When you use your chain rule, it gets a little tricky now with all the f's and the f of x's. Your g prime is g prime x. That's easy. Using the chain rule, though, your u is your inside, is your f of x. Your f of u is u squared. All right? Your u prime is f prime x, and your f prime u is 2u. All right? 2u times f prime x would be, you type back in your u, 2 f of x, f prime x. All right? That's your f prime x. Now, with your product rule, you have to cross multiply, so this does get a little tricky. It becomes 2 f of x, f prime x times g of x, plus g prime x times f of x squared. Now, we want to know when x equals, here's the key, 4. All right? So when this is 4, this is going to be 2 times f of 4, f prime 4, times g of 4, plus g prime 4 times g f of 4 squared. So we're going to use everything in this 4. F of 4 is 4. So these both become 4s. All right? So this is, I'm just going to put, so this is a 4, this is a 4. All right? F prime of 4 is 3, so this becomes a 3. All right? G is negative 3. G of 4 is negative 3. G prime 4 is 2. So 2 times 4 times 3 times negative 3 plus 2 times 4 squared. 24 times negative 3 is negative 72. 2 times 16 is 32. Negative 72 plus 32 is negative 40. So we know it's continuous at x equals 4. All right? So k double prime of 4 is less than 0. All right? Negative means it's less than 0. And since it's negative, it means it is concave down. Okay? All right, and that's it. That's all there is to it. Nice and easy problem. That's B. All right, let's go to C. Let m be the function defined by m of x equals 5x cubed plus from 0 to x f prime t dt. Find m of 2, and now you're going to show your work. Now, when we're finding m of 2, first thing you're going to do here is what? We're going to use something called the first theorem of calculus, the fundamental theorem of calculus. The integral of the derivative of f of x dx from a to b is f of b minus f of a. This is simple. Now we know that x here is going to be 2. How do we know x is 2? Right there. So we're going to do m of 2 equals 5 times 2 cubed, 5 times 8, which is 40, plus from 0 to 2 f of t. Now, from 0 to 2 would mean that f of b is 2, f of a is 0. So f of 2 is 7, f of 0 is 10. So 40 plus 7 minus 10, 40 plus negative 3 is negative 37. And that's your answer. I wish there was more work to show you or a trick that was to do, but that's as easy as it gets. You're not going to get a problem really easier than that. All right? Let's look at 5D. The function m is defined in part C as increasing, decreasing, or neither at x equals 2. Justify your answer. Now, what you need to do is the function at C is right there. So I'm going to write right there. So if m prime x is greater than 0, it's increasing. If the derivative is less than 0, it's decreasing. All right? Increasing, decreasing has to do with the first derivative. Now here is the function, and you're going to have to derive it. Now when you derive this function, the first thing you're going to do is derive the first part, and then you're going to derive the second part. When you derive 5x cubed, you get 15x squared. When you derive this, this is going to be f of x minus f of 0, so f prime x. All right? So the derivative from 0 to x of f prime of t, dt. All right, when I do this, it's going to be f prime x minus 0 is f prime x. M of 2 equals 15 times, how do we know x is 2? Well, it tells us once again. All right, 15 times 2 squared, 15 times 4 is 60. F prime 2, 2 f prime is negative 8. All right, I don't know why I did the extra step there, that's pretty simple. So you get 52 as the answer. 52 happens to be greater than 0. Since 52 is greater than 0, it's increasing. All right, nothing really to it. And it's a very easy problem. All right, we got one more left. Wow. Uh-oh, my button went down. We're back. Consider the curve by the equation 6xy equals 2 plus y cubed. Show dy dx equals 2y over y squared minus 2. You should know by now that this is an implicit differentiation problem. What you're going to do is you're going to derive both of those in terms of x and hopefully get that same answer. The derivative of 6xy equals the derivative of 2 plus y cubed. All right? You can use the product rule. Derivative of 6x is 6. Whoops. Derivative of y is dy dx. Once again, I did this in other problems, so I always forget. When you derive x to the n and x to the n minus 1, when you derive an equation and the variables do not match, it's still the power rule. You just do d, the variable you're deriving, over what you're deriving it by. Right? What you're deriving it in terms of. That's the correct speed. 6x times dy equals 6 times y. Derivative of a constant, no matter what you're deriving in terms of, is 0. Derivative of 2 equals 0. And the derivative of y cubed, 3y, 3 minus 1 is 2, dy dx. All right, so that's the first step. The second step is you want to collect everything with the dy dx on the left side and put everything else on the right side. So I'm going to subtract, I did it backwards. So I subtracted 6x from both sides, dy dx. All right, I'm left at 6y equals 3y squared, dy dx minus 6x dy dx. I'm going to factor these out, pull them forward, and be left with 3y minus 6x. And then I divide both sides by 3y minus 6x. And I end up with 6y equals 3y squared minus 6x. All right, you can move everything to the other sides anyway, it doesn't matter. The only thing is every single sign is going to change, which is okay, because you can always change them back by multiplying or dividing by a negative 1. This doesn't match, but what can I do? I could simplify this. I notice that a 3 goes into all three of them. 6 divided by 3 is 2, 3 divided by 2 is 1, so you get 2y over y squared minus 2x. They both equal each other. You just successfully showed that that's your answer by doing implicit differentiation. Right? All right. Whew. B. Find the coordinates of a point on the curve at which the line tangent to the horizontal, or explain why no such point exists. Now, horizontal tangent lines. What do we know about the slope of a tangent line that's horizontal? Has a slope of 0. All right. So, whoops. dy dx equals 0. So, since that's our equation, when we set it equal to 0, we just have to set the numerator equal to 0. Don't care so much about the denominator. So 2y equals 0 and y equals 0. So anytime you have y equals 0, you're going to have this being 0. But we want the coordinates. So we have the y, we need the x. we're going to take the y coordinate and type it in here and find out what the x coordinate is. So 6x times 0 equals 2 plus 0 cubed. 0 equals, wait a second, 0 equals 2. The x disappeared. So what could that possibly mean? We can't find the x coordinate now. So since when y equals 0, there is no x coordinate, I don't know what to do. Do you? Well, actually I do. It means there's no solution at y equals 0. At y equals 0, it's probably some type of asymptote because you type it right in, there's no solution. There's nothing on the graph. There's no point that, you don't put a point down where y is 0. So there's no point on the curve when the line is tangent to the curve is horizontal. So there is no horizontal tangencies for that particular curve. I did know those answers. I was just trying to make you not feel so bad. I was going to see, find the coordinates of the point of the curve where the line tangent is vertical. So vertical lines, they have slopes that are undefined. So a line tangent to a vertical is dy dx is undefined. So it's going to be your function over 0, something over 0, a constant over 0, a number cubed over 0, a square root of something over 0, a trig function over 0, anything over 0. So in this equation here are 2y over 0. So we just want to make this equal to 0 on bottom. Now here's the key. You have to reduce it first, because if you can cancel out anything from the numerator and the denominator, that's actually going to give you a whole. So that's a little bit different. But what we're going to do now is we are going to just set the bottom equal to 0 because nothing can cancel out. So y cubed minus 2x equals 0. Now, since this is true, we want to know what this is. So we have to go back to algebra 1, where you have two variables in equations, and you want to do the substitution where you want to make it one variable. So we want to isolate y by itself. So what we're going to do is we're going to isolate x by itself, x or y, it doesn't really matter. We're going to subtract y squared from both sides, and then we're going to divide both sides by -2. All right? So all I did here is I subtracted y squared from both sides, and then I divided both sides by -2. Negative divided by negative gives x's y squared over 2. All right? So now I could take this and take my original equation, and where I see the x, I can replace it with y squared over 2, giving me a single variable that I could solve for. You could do the same thing with y, but because y squared, you'd end up with square roots, and no one wants to deal with square roots. But you can if you want. So this becomes 6 times y squared over 2, because that's what x equals. 6 divided by 2 is 3, so it's 3y squared, and y squared times y to the first is y cubed. So you get 3y cubed equals 2 plus y cubed. I can subtract the y cubed from both sides, giving me 2y cubed equals 2. And then, ooh, this one's going to come out nice. I can divide 2 by both sides. Give me y cubed equals 1. I take the cubed root of 1. What times what equals 1? All right, y equals 1. So when y equals 1, this is undefined. But now we have to find out what x is. So we're going to take that 1 and we plug it back into the original equation. So 6x times 1 equals 2 plus 1 cubed. 6x equals 2 plus 3. 2 plus 1, sorry. 6x equals 3. Divide both sides by 6. X equals 1/2. So now we actually have a point. When y equals 1, in this equation right here, x equals 1/2. So my point is 1/2 1. So at point 1/2 1, there is a line that is tangent to the curve that is vertical. All right? And there you go. There's not an asymptote, it's just where the curve is, the line goes up and down, the tangential line. All right? One more problem. Breathe. All right, D. How long has this been going? Hour 10. This one more quick. Consider the curve given by the equation. Once we have the same equation, a particle is moving along the curve. The distance at which the particle is at the point, 1, -2, the one we just found, is horizontal position increasing at a rate of dx dt is 2/3 unit per second. What is the value of dy dt, the rate of change of the particle's vertical position at that instant? The key word here is rate of change. That right there, oops, not dy, d dt. Anytime you see rate of change, you are going to derive things in terms of t. What are you going to derive in terms of t? The original equation. So, we're going to derive everything in the original equation in terms of t. First thing, we're going to need the product rule here. So the product rule, the derivative of 6x in terms of t, x and t are different variables, so it's going to be 6 dx dt. Derivative of y in terms of t, 1 dy dt. And then a little cross multiplication, 6x dy dt plus 6y times 6 dx dt. So I can just put the 6 in front of the y. And we get 6x dy dt plus 6y dx dt. The derivative of 2 is 0. The derivative of y cubed is 3y squared dy dt. All right? Now, this plus 0, we can replace all this stuff now. So now we have some fun. We know that x, or dx dt, is 2/3, right? Given. Whoop. We know that x is 1/2, because this is our x, this is our y. So that goes here. We know that y is -2. That goes here, and that goes here. And we know that dy dt, we don't know what dy dt is. So we're just trying to find out this. 6 times 1/2 dy dt is 3 dy dt. -4, -8. 3 times 4 is 12 dy dt. We got it. Now, since we have 2 dy dt's here, we need them on the same side. We can subtract 3 dy dt from both sides, giving us 9 dy dt. Finally, you're going to divide both these sides by 9. And you get dy dt equals -8/9. All right, so the particle's position is moving -8/9 units per second. All right, if you want to put that, that'd be great. Units per second. Whoop, I'll add that on there. That's it. All right, so whoop, clear that up for you. We are finished with the 2023 practice review for the free response questions. We got 6 more questions in. Study these questions, study the formulas used to solve them, study the methods used to solve each type of equation. If you could do that, if you're comfortable with it, it's going to be an easy test. If not, not going to be so easy. But until you do the next review, take care.